Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, we're going to be testing out some motherboards. Hopefully at least one of these works. They all suffered battery damage, and I've tried to clean them up, but that doesn't mean they're going to work. And they're interesting motherboards. Let's first quickly take a look at what we have here. So we have a full-size AT386DX motherboard with cache memory. So it has a cache controller chip here. The processor has been removed from this board. This board, by the way, I didn't talk about the manufacturer. It's Micronics Computers Incorporated. Doesn't have a particular part number. It's got an LED up at the top here and a serial number sticker. And right down here it does say 33 megahertz, which will be controlled by this 66 megahertz crystal oscillator right there. And this thing has what looks like a Micronics chipset. So they made the chipset. They made the motherboard, they put these stickers all over it to say warranty void if removed. As you can see by this particular behemoth, it has a lot of DRAM installed, 16 megabytes, I'm assuming, 16 SIM sockets. There are integrated peripherals, so it looks like we have serial, parallel, floppy, and IDE. I mean, that's not very common, I don't think, for 386 motherboards, especially of the full-size variety like this. Now this did suffer battery damage right there. I did remove it and I tried to clean up a little bit, but you know, now that the board is dried out, it's been like a week, I noticed it doesn't look super good. So I don't know, we'll see what happens with this board. Moving on to the next one, if I can expose it here under this pile. Here it is. It's another 386DX motherboard. Also has the processor pillaged. That was not me that took it off. This one doesn't have battery damage because it's got a Dallas clock battery thing there. Oh no, wait, what? There's a space for the battery, but you know what? Doesn't look like one was ever installed on there. So this can obviously support both a regular battery and a regular clock chip or a Dallas chip. So that chip will be dead, but the good thing is there's no leakage. So interesting things about this board, it's got DRAM right here, and it has SIPs, which are SIMs with little pins installed on them. Single inline package, SIP, SIPP, whatever that stands for. I got some more, there's 3 of them on board here, one is missing, although these have 2 rows of chips. I think I have at least 4 megs, but the fact is, even without this memory, it's got this DRAM here, so it should probably work. This is a way to expand your RAM, probably in a 32-bit way, that if you don't have the proprietary RAM card, which would plug in right here, then you're still okay. It appears that this board has cache memory, I guess. I think that's what's going on right here, which is interesting. So this particular chipset must support cache memory built in. This is for the 8386 here, and right there is the 8387 Mathco processor. VLSI chipset. Looking at date codes on chips though, 1989 appears to be when this thing is from. It's got a lot of PAL chips here, which is what these little stickers are. That's all proprietary, so if any of those are bad, this thing's not going to work. And right there is the information on the boards made by DTK, so they were pretty prolific, making clones, the full computer with the case and everything. This is obviously the motherboard, the PEM-2500 cache 386, 25 megahertz. It's big. Now, it's also quite bent. Let's see if I can show this in the camera. That should hopefully show up. It's got quite a curve there. I can try to bend this back using some heat in this area of the board and just wear some gloves, and I've done it before on Commodore 64s, and it's actually pretty effective. You got to use a really high power heat gun though, put a lot of heat right into here very quickly, bend it, keep doing that a few times, and then it should straighten that out. Next up is this board, which is also a Micronics motherboard. There's the Micronics Computer Incorporated, copyright 87 to 92. Perhaps this right here is somehow the part number. MB225000873, I don't know, 33 megahertz. It's pretty dirty. It's got SIM sockets, so we have 8. Luckily none are broken, and they also have metal clips. Micronics chipset as well. Now this motherboard I thought was a 386, but I guess I don't know. I mean, I guess it's a 46. I think it's a 46. So we have an overdrive in here, DX40 PR100. So I'm assuming this is a 46 motherboard, and this is like a DX4 upgrade from 33 megahertz, which is what this thing would have been running at, to 100 megahertz. A built-in voltage regulator, and that's because a DX266 would just go right on this motherboard, but any of the DX4 stuff requires lower voltages. So unless the motherboard has the built-in voltage regulation adjustment from the 5 volts, you need to have onboard regulation. So this is not a Pentium overdrive, which you could get for the these types of 46 motherboards. This is just 46 overdrive. This thing also has a proprietary RAM slot here. So this would be like a big full-length card that allow you to add more RAM. Then this can obviously take 8 megs of RAM very easily if you use 1 meg sims, but perhaps at the time 4 megabyte ones were very hard to get, which you probably could put on here. So you'd use this proprietary RAM card here. Unlike that other motherboard, this does not have integrated peripherals, which is much more common, to be honest, for these types of AT boards. And this one also had battery leakage. And yeah, some of the traces are kind of eaten through a little bit there. Someone removed the battery before I got it, but I'm noticing there's quite a lot of corrosion still around this dip switch here, around this crystal, that I should probably try to clean up. But to be honest, it looks okay to try to get working, although I'm noticing there's even corrosion inside the keyboard BIOS chip here. So this motherboard may not work. Luckily, 46 motherboards are quite common, and this overdrive chip is pretty cool here, so I'll be stealing that off of this if this doesn't work. But yeah, we'll be testing that out. And then the last motherboard is a little older than these two, and this is a 286 board. Now, here it is. This is a 286. Someone has pillaged the CPU on that as well. We have a 24 megahertz crystal right here, so I'm assuming this is going to be a 12 megahertz board. Do I see anything about who makes this? It says Win386. What? That's confusing. Is this a 386 SX board? I don't quite know. But this has got a Dallas chip as well, which means it didn't have any leakage. There's space for a battery, but there's never been one installed, according, well, there's just no residual solder or flux or anything there. Board's in really good shape. I assume this is a meg of RAM that's installed in here. Let's just quickly take a look. Yep, 256 chips, so 1 meg total, so 640K plus 384K of extended memory. Very typical for a 286 board. G2 chipset, never heard of that. This does have an Intel 8287 math coprocessor, so someone pillaged, I'm assuming the 286, they left this behind. If this were a 386, I don't think, yeah, the 386SX uses a different math coprocessor than the 286, I think. You know, boy, my memory is foggy. I know it could use a different math coprocessor, but maybe certain motherboards could use a 287. Don't quite remember. It's just weird that it says Win386 there. Is that just like the manufacturer or something? I just don't even, that's confusing to me. I'm looking for date codes. There's one on that chip, 1989. The DRAM doesn't have date codes. Down here, 1989 as well. 88 on that one, 89. Okay, so it's like later 1989, this board. You have to remember that 286s, well, the very first 286 came out 1984 or 83, I think it was 84, with the IBM PC 5170, the PC AT 5170. But the 286 was still popular into the 80s, even though the 386 boards were out at that point. They were very, very expensive. So you could get 286 boards and of course 386SX, stuff like that. Anyhow, all right, well, 2 of these boards have battery damage and 2 don't. So I'm gonna grab the test bench power supply stuff and let's see which ones of these power up and seem to work. All right, so this is my 46 DX33 test bench and it's hooked up to this monitor here. Power, let's just turn this on. Should get an image. I'm gonna get the postcard and my keyboard and I'll pop this motherboard. Okay, there we go. Real-time clock battery is discharged. Really? Anyways, we're not here to troubleshoot this board. We're here to take a look at those other ones. So I know this works. So we'll just get this stuff off of here. And I think we're gonna start with this one. This is the 486 DX, whatever, 33, I guess, with the overdrive, because that is the first one that I grabbed. And yes, this is what we're gonna test first. So I am noticing there is some crust on these connectors here. We get some magic eraser. We're gonna try to clean this a little bit. Whoops. Not that I think it wouldn't make a connection, but you know, I don't know. I'll just put some on this magic eraser, put some Deoxit that is, and we'll rub this on here. That helps. It gets off quite a lot of the crust. Magic eraser and Deoxit, it's a good combo. Now this is the motherboard here that had a lot of the crust here around the dip switches. So I'm not really holding out hope that this thing is gonna work. First thing we're gonna do is we're gonna apply power, and we're gonna hook up a postcard to this. That's gonna show us any BIOS post codes. This is a postcard right here. So this reads the post codes out of the system, and it will display them on this little LED screen. It also has a little speaker here, which is what this wire is for, so I can get some beeps out of it. And there's LEDs to show you what the voltage rails are. What a post code is it's an IO port. Essentially, Intel processors have memory, and then they have a separate set of address space that's called IO addresses. And those IO addresses are used to talk to cards and things like that. Well, I guess IBM designated a particular IO address to be post codes. So as the BIOS starts to boot, it writes a byte at a time into a post code. So you have basically up to 255 possible codes that can be posted there. And all this card does is it monitors that particular IO address, the standard one that's agreed on, and it will just display it here on this little display. So if we plug this in, and it supports both PCI and ISA, so we're gonna pop this into one of these slots here. If you plug it in and you power it up and you just see 2 dashes on the little display, that means that no post codes have gotten written into that IO address. Now, if the BIOS isn't supporting post codes, it's never gonna write to it and you won't see anything. There are some really old BIOSes that don't support them, but I see right here, this is a Phoenix BIOS. So if that BIOS is working and this processor is running, then this should actually show some signs of life. Now, the damage that's happened on this board over in this area, though, could easily cause the thing not to post, because these dip switches here have been bathed in battery juice, which can easily cause a problem. So who knows? We'll have to see. And the thing is, of course, is this is that Micronics board, and I have to go look at see if there's a manual, but I don't even know if these switches are set correctly and all that kind of stuff. First thing we do though is let's just see if there's any signs of life. Hey, it's posting. So that's it. So that right there is a great sign. There is a sign of life on this machine. I'm gonna plug the speaker in. So the thing is, okay, look at that, it posted. Yeah, 46 DX4 at 100 megahertz. Ooh, and check that out. It's got 16 megs of RAM. That's pretty cool. That means the SIMs that are on this board aren't just the standard 1 megs I thought they were. They're more rare 4 meg variants. Awesome. Now, one thing is the keyboard may not work, and I haven't touched a key on here. It does have a light on here, but the fact is that corrosion in that area there, it's not always a good thing. Let's see if I hit F2. Wow, it is freaking working. That is actually quite amazing. So this board, look at that, went right into the BIOS. Wow, I'm very surprised, to be honest. That's pretty cool. I think what I'm gonna do down here though is because there's all that corrosion, which I have to say, I did a lot of cleaning, scrubbing. I put corrosion inhibitor stuff on there. I'm gonna put some Deoxit into these dip switches here, and I'm gonna manipulate them. You know what, maybe I should just leave it all be. I don't even know what those dip switches do. This thing is working. Yeah, maybe I'll just leave this alone and I'll just put some Deoxit in the switch and on this chip, which has a bunch of corrosion, and on this crystal and just around the area here. I see a bit of green crusty over here as well. I'm just gonna bathe the area in it, and I'll just leave it. I'll just leave it on there, I think. Yeah. Sorry about that. The furnace just came on, even though I have it set for disabled. Don't know what's up with that. Anyways, like I said, you should probably, take all these components out, especially the larger ones, like the dip switch blocks and stuff. Those can be easily replaced. There's nothing special there. This large IC here, this is like part of the chipset. That obviously it's a bit unique, but these ICs are just normal. Keyboard BIOS, all this stuff is like pretty run of the mill. So it would be replaceable if any of this stuff got damaged. What I'm doing right now is I'm just using the tweezers to kind of scrape on any of the green crusty corrosion with that Deoxit. Kind of just takes it away, to be honest. But like I said, you should take these chips out if you have a board like this. Oh, look at this. I see some green right here on these resistors. So I'm just gonna scrape a little bit. You should take this stuff off, clean underneath, scrub it away, get rid of any signs that any of that green crust is there. And that just helps prolong the life of the board. Now, I'm definitely not gonna do that in this video. I just wanted to make sure this board works, and oops, now I got Deoxit all over my gloves. It seems to, and so what we're gonna do, so I'm gonna plug the power cable back in, and we are gonna boot up with this, my XT IDE, full of utilities and things. There's certainly a lot of, I'll put some Deoxit on the connector. These are very dirty. This board was absolutely filthy. In fact, it's quite a lot cleaner now than it was. Oh, these slots are kind of crusty. Yeah, so a bunch of utilities are on this XT IDE. VGA card, post card, we don't need to look at it anymore because we know that it's working. We'll power this up. Let's run through a few diagnostics on this thing. Drive error on A. Okay, yeah, we don't need that. So let's go into the setup. So I'm just gonna set a random time just because it had nonsensical things. Oops, I keep pushing the wrong buttons here. I just like to set something that makes sense for a date. 1998 is fine. I'm gonna turn off, I'm gonna turn off the disk drives, disable those. Fixed disk, we need none. External cache. It does have cache on the board. Let's turn that to enabled. Okay. And this page here under advanced, setting items on this menu to incorrect values may cause your system to malfunction. Oh no! So large disk DOS compatibility. It's funny how like it changes to white. It could be the monitor setting, to be honest. Like when that line is selected, we can no longer see that text anymore. Anyways, we'll go into advanced chipset, and what we have here, I can't read it, but it says additional IO cycles can be added for slower cards. So this must be some kind of like wait state thing. 6 was the default. I don't know, let's go right to 0. Let's just go right to fast. Security settings, you got the virus check, blah, blah, blah. And we're gonna save and exit. All right, I like the nice summary screen, and there's the XT IDE. And it looks like it's booting, it's just taking a second here. I must say, considering that this board looks like it was like Left 4 Dead, it's filthy, and it had a battery that blew up all over it, and it has this cool 46 chip. It's nice to see it just works. That's I have to say, I was assuming the worst, and this is really a nice change. All right, let's run good old speed sys. Oh, that's not gonna work because we were running EMM3D6, so we'll reboot. This will help us identify like cache memory and make sure that the cache is actually working. So with things like SpeedSys, you just need to make sure you boot your computer with all of the startup stuff disabled. So you wanna not have EMM3D6 working. So this is problematic. Determining system contents, memory type, and just, it hung. So that could be a fault on this particular board, but it could also be that I turned on the cache and that's not working. Setup is dead. And that's interesting, even turning it off for just a second, it lost all the settings. That's pretty frustrating. I'm just gonna leave it set for external cache disabled since the settings got reset anyways. The time and date didn't get reset, but the diskette type did. That's interesting. We'll just leave it set to you know, all the defaults essentially, which I think is, well, I don't know, we'll see what happens here. All right, let's try again. Let's start with speed 600. Definitely working. DX 100 megahertz, cool. Let's try speed sys one more time. Definitely looked like it froze on the second try as well. Let's reboot again. Oh, control delete actually worked. That's interesting. And let's check out and look, it's at 6 cycles as well, and it was still freezing. So this thing may just have a fault, or maybe I didn't wait long enough. Let's reboot one more time and wait a little bit longer. And then if that still crashes out, then maybe I'll just, you know, try some other tests on this thing, see if it seems to be working properly. Maybe Speedsys doesn't like this Micronics chipset that's on here. That's possible. Yeah, it's just frozen again. I'm going to try the program cache check here, and the cache is disabled right now in the BIOS, so it should only have whatever's built into the 46, which is one of the big differentiators between the 46 and 386, is the 46 has an internal level 1 cache, which is very fast, and that's what, you know, increases the speed of the 46 over the 386 quite a bit. I think the L1 cache is pretty small, 16K maybe. I can't quite remember. Like, this is memory timing tier, or like microseconds per kilobyte. And everything from 1 to 16K is actually fast. Everything after that is slow. So yeah, my assumption is, again, that it's 16K, but we'll let this run through and see what the answer is. While this runs, you know, what's cool about this overdrive processor is it's very common to find a 46 board that runs at 33 megahertz. Those are very, very common. And this is, instead of a clock doubled like a DX266, this is a clock tripled. So it still is a 33 megahertz bus on this machine. So this is just drop in, plug and play. But then it's tripled internally, so it actually runs at 99 megahertz. And there it is, cache is 16K. So yeah, that's the level 1. Let me reboot and turn on that external cache, and let's see if that changes this. Okay, we're running cache check again with the cache enabled, the external cache, which is right here on the board, by the way. Yeah, okay, so I think there's a difference here. So that's 11 for 16K, and now up to 64K is 21, and this must be 64K. These chips are MT5C64s, yeah. So this is 64 kilobytes. But yeah, this processor's cool. It's just, you drop it in, and whatever old machine you have that's not really expandable past 33 megahertz for a 46DX, the regular one, or 66, you're going to be sporting 100 megahertz. And it's pretty good, it's pretty fast chip. Now, they did make Pentium overdrives as well that would plug into the same socket and work at that same 33 megahertz, and then it would have a Pentium core, and that had a lot better. So yeah, here we go. L1 cache is 16K, L2 cache is 64K. Cool, all right, well, this board, there's not really much else to do. I mean, it seems to be working. I don't know why Speedsys is crashing. I suppose we can reboot and then I'll run a game like Doom, and that will be the final test to make sure that it works. I was trying to load drivers for the Sound Blaster, which of course is not installed, so that's not gonna work. I think Doom should start, even though I don't have a Sound Blaster plugged in, and I'm sure it's configured for one. What will happen? By the way, this version is not shareware. You must report software piracy to 1-800-388-PIRATE. P-I-R-8. Pirate. Let's see how the performance is. I'm sure it's pretty nice. The frame rate is okay. I don't know, is this running even at 35 frames per second? I guess it is. Or maybe not, I don't know. Either way, it's working, it's not crashing. This board freaking works. That is awesome. All right, next up, we're gonna do this, the bent board that doesn't have any battery leakage. What I do need to find is a 386 processor to stick on there, which, going into my little thing of chips I have right here, so 386DX25, and this appears to be exactly that. I see a 50 megahertz crystal here, so that implies that that is that speed. And then I have this for testing as well. If the camera focuses, we have an advanced math processor, coprocessor here, 40 megahertz. Pretty sure this is just an 8387 basically. It should maybe work there in that socket, or this one here. I think it's that one. Okay, let me get this in the board. I'm just gonna put some Deoxit in that socket. It's not dirty or anything, but it just makes it a little easier to get out down the road because it's got that lubricant in it. If you watch my channel, I'm sure you already know that. Give my chip a little check for any bent pins. Looks good, I don't see any. Okay. And there's a dot on the board for pin 1. Power supply and postcard. So postcard in. Now there's a missing memory module there, so that's gonna cause a problem, I'm sure. That's not a good sign. It's doing something, right? It's like, it's showing it's happening is it's going between FF. Just try to turn this. It started at FF, it was 00AA. That's not normal for postcodes. Oh, this is a DTK BIOS though. I don't know. They're weird sometimes. They don't work very reliably. I'm going to pop these memory modules out since we're missing the extra one anyways. I don't know how big these are. Now, I do have some more SIPs. I can pop one in. Let's see if it gets to focus. There's a SIP. So it's just a regular 30-pin SIM, and then they've soldered on these pins here. That's all it is. If you could find these pins these days, you could make some more just by taking some regular 30-pin memory and adding the pins on. That's all it would take. But those pins nowadays are kind of unobtainium. At least I think they are. It does kind of never ceases to amaze me though, where people find stuff like they're like, oh, I found a source for, you know, whatever. These memory chips, by the way, are 1 meg. So this is actually 4 megs of RAM right here on the board. Let's hook the speaker up because maybe we're hearing beeps. Okay, so that totally sounds normal, that beep. So this particular BIOS by DTK must not support postcodes. DTK, you kind of suck. I gotta say, you kind of suck sometimes. All right, card's in, turn that on, plug in the keyboard. Yeah, just that single beep. There it is, look, it's posting. DTK 386 computer, Datatech 386, 1988. So yeah, it's seeing 4 megs of RAM. It's exactly what I thought it was gonna see on here. And we're getting issues for setup. Press F1 for setup. Look at that setup. Not very fancy. Set up the system configuration. All right, 1, enter. Oh, look at that animation. The date is 7?80. So we do what I said, 1988, I don't know, whatever. We'll put in an old date. Time looks fine. Coprocessor currently says none. Disk drive say none, which is fine because this doesn't have integrated peripherals. And we'll hit 9 for exit. It's all correct, yes. Where is the XT IDE? I'm gonna try to plug this in quickly because does this thing has the Dallas. Yeah, this has a Dallas on it. So I think Dallas is when the battery is dead, which it is here. In fact, that didn't even work. Okay, well, whatever. We'll plug this in quickly. There we go. With a regular BIOS chip, like not the Dallas type, but the other ones, they typically retain their settings for like, you know, a minute or 30 seconds, even when there's no battery installed. So you can shut the machine off, plug a card in, do stuff like that, and it does work. But these, not so much. I love this. Set up build-in utility. Build-in? Is that built-in? With a T? Is build-in? All right, let's go back to here. Okay, so the date and time are fine. I don't know, everything's fine. Why is it complaining about the floppy drive? There's no drive configured in here. Maybe I just need to go in here and like pick none. Just do it. Okay, fixed disk. How many fixed disks? 0. Okay, exit. Is this correct? It is indeed. System will now restart. Check battery. Floppy drive error user check. FDD seek failure. Display card mismatch. Run setup. Really? Let's check this build-in utility here. System utility disabled, timer enabled, calculator enabled, both enabled. Oh, I forgot. You push some hotkey and like a DOS, like a text mode calculator appears. I guess there's a timer. We'll just leave those at disabled. We don't need those. Okay, quit setup program. Hopefully we'll just go past the error that pops up at boot. Yeah, these Dallas chips are nice because they don't destroy the board when they leak, but they're just a pain on the other hand. But they can be modified. There are, if you Google or look on YouTube for videos on how to modify them to add a battery, or you can just buy modern replacements. We're gonna hit any key to continue. All right, there we go. It's booting off the XT IDE here. Let's see if this thing is working. Now this looks like it has cache memory right here. So does it actually work? I don't know. These chips are 25 nanoseconds and they're VT6288s. I don't even know what that is. This could be the problem with the BIOS. Okay, it's okay. There it goes. Oh shoot, I didn't hold down shift. So it's gonna load now. All right, well, if this tries to run my auto exec, I'm going to put the math coprocessor in there. Wow, it does seem to be going really slow. Okay, one possibility turbo jumper. Some motherboards require a jumper for turbo, and this one might be one of them, and that might be explaining why this is very excruciatingly slow here. I'm gonna hold down shift again. Hopefully that boots into DOS more quickly. And while we wait, the long wait, I'm gonna get my little thing of jumpers here so we can install the turbo LED, or turbo switch, which is just gonna be simply a jumper. But if we can get into DOS with this thing, then I can just run speed 600, which real time will show us what's happening with the clock speed. Let's plop this on here. Oh, okay, well there we go. Utils, speed 600. Okay, here we go. How fast are you going? That is slow. How about with this off? Aha, it's fast without a jumper installed. And there are 2 positions for the jumper. And I'm sure, oh, either of them make it slow. Okay, there are 3 pins is what I meant to say. And yeah, they both do the same thing. So on this motherboard, if you have one of these, jumper removed for full speed. And if we do a retest here, there it is, 25 megahertz. It's the equivalent of a 43 megahertz 286 AT, as in the first IBM PC AT. So that thing ran at 6 megahertz. This is way faster. Let's try the old speed sys that did not work on the last one. Oh, this doesn't work because it needs at least 4 megs of XMS memory. Okay, well, still gonna try to run. I just wanna know, is this cache memory working? Is this frozen again? Maybe something's wrong with my copy of this program. Yeah, weird. Yeah, maybe it's somehow corrupted or something. Let's reboot, and I'm just gonna run cache check. I just wanna know, is this cache memory, is it working? Now, this is actually kind of funny, while we're waiting for this to boot. I didn't know if this processor worked. I just had this in my spare parts, and it does. So it's getting a little tick mark on it. So I know that's a good 36DX25. And then I need to test this ULSI. I have no idea if this thing works or not. I think this is a pretty fast chip, if I recall. So let's see, cache check. That's what we want. When do we want it? We want it right now. Caches on 386, I mentioned this in the last part here. The chip does not have it built in. There's no cache memory on the die. It would have to be external always on a motherboard. Now, level 1 is what's inside of a 486 or any other processor. It's the fastest. But when you don't have any cache on the chip, then I think this is now called level 1 cache, what's on the motherboard. And right away, we can see here, it's got 64K. Yep, cache is 64K. So that's kind of cool. That's a little unusual. I mean, not every 386 would have a cache memory on the motherboards. Well, I mean, maybe that was pretty common. To be honest, I have to admit, I don't have a lot of 386 boards because they're very often destroyed by batteries. So this is, I just don't have a lot of experience. 386SXs very rarely have external cache on them. But I think even for a 386DX, it's not a guarantee that it will have cache. 46s aren't even always cached as well. There are some, like my old compact Desk Pro, the all-in-one with the monitor in it, that has no onboard cache on the motherboard at all. So you only have the L1 cache on the chip. But like I said, I don't really know much about 386s. I just don't have that many of them. So this one's got a cache memory and it works, which is awesome. Although look at the speed, 63 microseconds per kilobyte. And on the 46, the L1 cache was like 11, and the motherboard cache memory on that 46 we just tested was like 21, I think. And this is 63. I think it's even slower. The cache speed is slower on this board than even the 46's main memory on the motherboard. And then 118 microseconds per kilobyte. Anyhow, okay, cool. Time to shut this off and get this chip in there. Now this socket here, I know you can't see it super well. It's bigger than the chip, but I think that's normal. So I'm just gonna put some put some Deoxit. Deoxit does not make your computer faster, no matter what the bottle says. Just kidding. It doesn't say anything about that. But we just pop this into the middle there. So it has like an even row of pins all around. Click it in. And let's hope that that doesn't kill it. Computer's working. That's a good sign. Getting some silly errors there about the floppy drive, but that's fine. We're gonna bypass all of this and we're just gonna run speed 600. I don't really know how to test like the math coprocessor speed and performance versus the Intel one. I don't even think I have an Intel one of these math coprocessors. So let's see what happens here. And then if it works, I'm gonna call this motherboard good and we will move on to the next board. So first off, speed 600. Okay, so yeah, it does have the ULSI 83C87. They had to use like a different part number to not run afoul, I guess, of Intel's thing. It says it's running at equivalent of 98 megahertz. That doesn't really mean a whole lot. It's, I guess, more like a 98 megahertz 8287. So, well, one of the boards we're gonna test has like an 8 megahertz or 6 megahertz or something, 287. And this is like 98 megahertz. So massive performance improvement when you got one of these motherboards in what year? 1989, I think, is what we determined this board is from. And you came from a 386, or you came from a 286, I mean, or you came from an XT. Even though this thing's only 25 megahertz, still, the fact that it's got cache memory on here, this board was a performer. This would have been a really substantial performance increase. Of course, 46 came out not much longer after this, and that was a massive improvement, and that's, of course, because of that level 1 cache in the processor that runs so quick, and it's able to keep the pipelines full and all that kind of good stuff. What can I run? Check it. Why don't we run Check It? I think that's got some tests for the Math Co Pro. Don't worry about that weird font. That happens because of Speed 600. Look at that, DTK BIOS, it recognizes it, and 8387 Math Co processor. That's not normal. I don't normally have a little bit of garbage on the screen there. Strange. And the letters are kind of messed up. Let's test the system board here, though. Test the number processor unit right here, and that all passed. So everything is passing in here, and let's just check main system benchmarks. I still don't know why the main screen has that weird junk. 7366 dry stone. Sorry, we didn't even test with the 46, but we can do that in the next board we test, if it works, of course. And it's testing the 8387. Ooh, there's a lot of heat coming off this. 341 times faster than the PC XT. And I think that's like the XT without a math coprocessor, but it's 21 times faster than the XT when it comes to just raw processing power. So what a substantial increase. Anyhow, okay, cool. This board appears to be working completely without issue. Okay, I wanted to show off the chips installed in the board. There it is. There's that math coprocessor, and see what I'm talking about, how there's extra pins around it? That's just normal, I guess. I don't know if the Intel chip has more pins or what the deal is, but there we go. Cool. Okay, so I'm gonna use my little fancy tool here. Someone sent this in. I have a couple of these. This is actually an Intel branded tool, if it can focus. And this helps you lift out these chips out of these sockets, because certain ones of these, I mean, this is a ceramic package, right? Because you can tell it's that purple. If you're not careful, you can actually, if you try to use a screwdriver, that is, you can break the package. So you have to, these tools are good. It spreads the load over a wide area. Now, the issue with these tools, though, on the other hand, is when the chip is really stuck in there, because it's been in there for a long time, then it can be really difficult. And I actually start it using something like this. I just gently lift it up a little bit. That kind of gets it going, and then I can use the Intel tool. Otherwise, it is just kind of thin metal, and even though it's got like reinforcing gusseted parts, it still bends. So that chip gets a check mark because I never tested that. And this motherboard actually will get a tick mark as well. I'm going to stick it up on the top here just to say that you are good. Neat. You need a big case to use this motherboard, obviously, hence the full-size nature of it. But it's quite a capable board. 4 megs. You could easily add another 4 here, so you have 8 megs. Or I suppose if I took these 4 megabyte modules right here that were on that last board and then soldered on these little pins so I could find some, then I could make 4 megabyte SIPs to go in here. This thing would be rocking tons of memory, 20 megabytes, tons of RAM. That's awesome. I didn't get the RAM card for this, or although, it's funny actually, because I had a card floating around. Where is that thing? I had a RAM card for one of these. Is this it right here? Here's a RAM card, but no, that's clearly not it. This is for something. Who makes this? It says made in Taiwan. HMB, doesn't really say. Does have this high density RAM here, which is kind of cool. It's missing one of the screws. But clearly that's not gonna plug in to this board. So I don't know what that's for. I just got that with something else and you know, who knows? Okay, working, 2 working motherboards, 2 to go. Let's move on. All right, here we are. This is the 286 board that has 1 meg built in. I happen to have a 286 chip right here. This is the Intel Gubbins. Okay, which way does this go on? There is a dot and there's a corner cut off on the chip. That would go this way, right? Like that. PLCC package. Oh, this has got the little feet on the bottom. You just push it into the board like that. So this is an Intel 12 megahertz part. Let me get those feet off here. Just hate it how it wobbles around. I'm gonna use the special tool designed to get those little standoffs off. Sent in by a viewer. Yeah, it's a Bic pen. And these are the standoffs on the back here. There they are. So you just push this down onto it. And usually they just come right out like that. Very easy. Easy peasy. All right, look at the back here. I just noticed, you see all this, these pins here. It's because it has 2 different types of memory chips here. This can support 4 megabytes on board or 1 megabyte, which is what's on here. The 1 meg chips are larger and they just take a bit more space. Same chips actually that were on that 386 board we just looked at. So yeah, I like these. These are cool motherboards. You do have to change the crystal to go faster because it's 12 megahertz here, or 24 megahertz, which divide by 2 for 12. So it's possible, I don't know about this G2 chipset, this thing might run at 20 megahertz. I actually have some 286's Harris parts that can run that fast. So you can try swapping this out, but some of these chipsets are limited to maybe 16 megahertz, and then they stop working. The Dallas chip I'm noticing is in a socket, so that's handy. It's not soldered in. I didn't even look at that other one. There are a bunch of jumpers. Oh, look at this. It's got freaking multi-IO. 2 serial and parallel, but how weird that it's got serial and parallel, but no disk. I guess this SIS chip here is providing that multi-IO capability, and I'm sure those jumpers there have to do with enabling and disabling these ports. But like when you have this many slots available, I mean, what's 1 card? I mean, I guess it was a value add, right? They added it in there so you didn't have to buy the card. Yeah, it just seems like a little superfluous. Having like a disk controller feels a little bit more useful. I don't know. Maybe that's just me. Okay, well, same drill as before. Okay, post card connected, plug in the speaker. This could have the same turbo jumper thing where you need a jumper to make it fast. You know, your mileage may vary on that. It really depends. Okay, I think we're ready. Okay, we're getting postcodes. Another working motherboard. It's like, this is good track record here. Didn't hear a beep though. Maybe I don't have this plugged in correctly, I don't know. Let's plug that in. Let's plug in the video card. There we go. Let's plug in the video cable. Power this up. Do we get a post? Yes, there it is. Phoenix BIOS 3.1. And like I thought, 1 meg of RAM, which is, yeah. Strike F1. Let's try to get into the setup there. You gotta be kidding. Is there no setup built in? It just says strike F1 to continue. Invalid config, please run setup, and that's it? Phoenix, what are you doing? There's 2 chips right here. I could easily just swap them out with another board, but I'm pushing delete, pushing F2, nothing. F1 just continues the old boot process. Oh yeah, so this is the one that has the math coprocessor on board. Right, cool. Let's go to the old Speed 600 here. Let's see what we get. Okay, so that is really hard to read. Let me try to fiddle with this monitor. You know, this is ridiculous. Brightness and contrast. Okay, yeah, it was the contrast was up too high, so that was my fault there. Okay, I don't know why that was like that. I must have done something. All right, it's running at 8 megahertz. That's not right. this thing must need a jumper. Let's find the jumper spot. Get some of these out here, or just one of these out. Those are tiny jumpers. There we go. All right, there's a 3-pin connector for turbo. That didn't do anything on those two. There we go, that worked. All right, what we can tell right here, let's retest F9, I think. Okay. So yeah, 11.6 megahertz. It's running at 13.2, so it's a little bit faster than the original AT, which is actually kind of interesting. I'm not quite sure why that is. This thing must have slightly better timing than the original AT, because the original AT that this thing is based off of, you put it in like an IBM and it's running at 6 megahertz, it's just going to say 6 megahertz down here. Like, it's basically the same clock speed, and what this relative number is the same. This is saying it's running at 5.8 megahertz for the Mathco processor, and that is because the Mathco processor very typically on most 286s run at half of the clock speed of the main CPU. So if you have one of these chips, and this one is labeled -10, so it can run up to 10 megahertz. The fact is, if you have one that's like rated -6 and it's on a 12 megahertz board and you're like, I don't understand, that's why. Half speed, very typical. It is possible that there's a jumper that changes that. There's a jumper right here. What if we move this to the other position? I don't know what this jumper does. Maybe nothing. That did nothing. There are some other jumpers on the board over there too. You know, I don't know. I'd have to look it up. Sometimes there might be a jumper to control whether the Mathco processor runs at half speed or at CPU speed. This being a 10 megahertz part, obviously would be overclocked if we're running at a CPU speed on this board. So this is the more typical configuration. But anyways, nice to see that this 286 board, it just freaking works. Now this is the one that had no battery leakage because of the Dallas clock chip. So, I mean, what do we expect? But that's still cool. You know, these aren't the most common boards anymore. So that's awesome that another one here works. Look at the main system benchmarks. So yeah, 11.6 megahertz. So we're getting 2,000 dry stones. I already forgot what the other machine, the 386 just got. 7,000, I think, 6,000. Yeah, 6 times faster than an XT. Wasn't that other one like 21 times faster than an XT? So I think it was like 7,000. And then the math speed on this is 34 times faster than the XT. And on the other one, it was like 90 times faster, if I recall. So significant speed boost, even though this is not a bad board. Now, one thing about 286 boards, by the way, all the performance is to be had on these is when you can set them to 0 wait states. These clone type motherboards have that capability. The IBM PCAT, it always runs at 1 wait state, at least as far as I'm aware. I think it's because the RAM on it is really slow. You need to put fast RAM on this. This is 100 nanosecond RAM, not that fast. But if you put like 80 nanosecond on here and you set this to 0 wait states, I think in, maybe not here in Check It, but in Speed 600, you'd be getting more like 16 megahertz on a 12 megahertz machine. That's more typical. I wouldn't be surprised if there's a jumper on here to enable the wait state, 0 wait states. It wouldn't be a BIOS option. It would just be a jumper on the board. And that's because, unlike on later machines, where the chipsets sort of were different from one chipset manufacturer to another, the 286 chipset on this board, which is this G2 stuff, it essentially is taking all the chips that were in the PCAT motherboard and like condensing them all down into these chips here. A little bit of extra capability, like, you know, the extra RAM, so it supports like the extended memory, and also maybe like if it's 0 wait states. But essentially, you can take a BIOS from the IBM and put it on this motherboard and it's gonna work. It doesn't know the difference. The BIOS can't tell, IBM BIOS can't tell that this is not just a normal, IBM motherboard. Now, of course, it does have overclock detection capability. I talked about that in my video. The BIOS that Stuart patched for me gets rid of that, so that would allow it to work on this board. But you could take this BIOS and put it in the regular IBM and it would work too. Like, it's all compatible, so you can move the BIOSes around. There may be some exceptions to this rule where there's a 286 BIOS that's customized with like options to fiddle with stuff, you know, soft switches basically. But generally, 286 boards have jumpers to configure all the various things, and the BIOSes are completely swappable from one to another, as long as they, you know, fit in the amount of space that is available in the 2 ROM chips here. It's a high and a low ROM chip because it's 16-bit data bus. And yeah, anyhow, I don't know what else there is to say other than, sweet, this thing works. That is very cool. I'm just gonna probably leave that 286 on there because I have a good number of those, luckily. So I'm just gonna give this board the old tick mark of success. And the downless chip is dead, we know that, so I'll just put an X on that. Wow, the math coprocessor gets hot. I was just had my hand on it, kicked the board out there. And that's a warm one. Okay. Yeah, that's right. The other cool thing about this, right, is that it has the I/O ports built in. Anyhow, gets the tick mark of success. Sweet. Alrighty, here is the last board. It's this 386 with all the RAM. That's right, I have the processor sitting right there. Math coprocessor goes there. And there's just a little bit of crustiness visible there. There was quite a bit more and I cleaned it up. But yeah, it looks okay. Will this board work? Who knows? But I can say one thing, by the way. With the postcard, if you put it in a computer like this, and there's no processor installed, it's not gonna do anything. You need the processor for it to do anything. You also need a working BIOS chip for it to do anything as well. Without a working BIOS, there's no code to execute, and it is the instruction code in the BIOS that updates the display on the postcard here. I'm noticing on this board, there's a little, the corner's caved in right here. Someone must have dropped it. It's pretty heavy too. I don't think that it's gonna cause any kind of damage or prevent this from working, but yeah, heavy motherboard. It's anyhow, okay, there is no processor. I'm gonna turn this on just to demonstrate that you get nothing. Nothing's gonna happen. It's impossible for it to display anything. You can still check the status LEDs and whatever, so there's that. There was a little FF that displayed momentarily. That is normal. That happens when you power things off. Just little glitches and stuff as the power rails fade to 0. Okay, Deoxit in that socket. Find the 386 here. There's no dot on the motherboard, but this has like a notched, like a little in the silk screen. The notch matches the notch on the 386. Is this 25 megahertz, this board? I know we saw somewhere that it was. Oh, it says right here it's 33 megahertz actually. So this, I don't have a 386 that would work in this. Now actually, that reminds me, I do have a Cyrix chip. Maybe I should get that out. I mean, this may boot anyways, overclocked. I'm sorry, I'm off camera here. I'm just grabbing the Cyrix chip. So this is some kind of a 46DX thingamajiggy. I wrote dead or bad on there because I don't know if this works. It is 40 megahertz. So if this chip doesn't post in here, we may need to try the other one. I don't know. Let's see what happens. I mean, these chips can be overclocked, right? It's just, it might work. Hey, look at that. It's freaking working. I can't even believe it. That's amazing. So that's just being overclocked. All right, let's plug a video card in. Let's see if we get, oh, that's really hard to go in. Let's see if we get anything on screen. I mean, if this thing is not quite stable, well, that could easily just be due to the overclock. But to be honest, I'm gonna try the Cyrix chip next. Okay, so the video card in. Hey, it's posting. It's freaking posting. It's overclocking. That chip, let's plug the keyboard in. It's just sort of hanging here though. That could be a problem. Oh no, there we go. It's testing the RAM. 16 megs of this stuff. Haha. Nice. I can't even believe it. Yeah, there it goes. 640K, 384 reserved. That's for like the upper IO address space for the cards and the BIOS ROMs and stuff like that. And then that extra stuff, invalid. Please run setup. Oh, tell me that this is like the 286 where there is no setup. Ah, what's the deal with Phoenix? Oh no, it says F2 for setup. Okay. Ooh, that's hard to read. Clock chip lost power. You don't say. There's no battery on here. CMOS checksum invalid. Fair enough. So we'll just put in some random stuff in these numbers here. Okay. Oh, it started at 1990. That was the default date. Get rid of the disk drive. Get rid of the hard drive, which is type 2. Weird, because this is IDE, it looks like. Display is not CGA, it is VGA, EGA, and CPU speed fast or slow. I mean, we're overclocking this baby. Wait a second. It's not even hot. Wait, what? How's that possible that this chip's not even warm? Now, by the way, you might be wondering, like, what's this other ceramic chip on here? That is not a 3D6. That is an A82385-33. That's the, I'm pretty sure that's the cache controller. That's Intel's cache controller. So these cache chips here, this was a chip they made to handle the cache memory. How much cache is this? It looks like 64K of cache memory again. Okay, it's a little bit warm. I mean, barely warm, barely warm. Wait, I hit escape. I wanted to save. I didn't expect it to just exit like that. Okay, let's try that again. Now, I don't know about this Cyrix chip. I don't know if you have to, like, you know, change jumpers or what, if we can just run this at 33 and it'll work, but I'll be very curious to see if this works. I think I've got this on a motherboard that did work, but I had to take this chip off and then it worked with an Intel chip on it. F2, okay, here we go. So it did save. Huh. Weird. I didn't hit save, I hit escape, but it says F10 for save. We'll do that. And then I'll plug this card in so we can get a little boot action here. See how this thing is doing. Oh, these slots are hard to get cards into. There we go. I'm amazed. I am amazed. 4 for 4. I mean, I shouldn't count my chickens before they've hatched, but 4 for 4 with these battery, you know, 3 or 2. 2 were battery damaged and they work. I'm amazed. Okay, moving 256K reserve memory to extend for a total of 15232. Okay, I guess it knows that it doesn't need all that cache memory up in the upper memory bank. I wonder if there was a second page. Anyways, okay, here we go. Look, it's booting. It's booting. Oh, that was booted way quicker. Okay, let's see. Speed 600. Let's start with that. Rockin' 33 freaking megahertz. Overclocking this thing. I mean, this chip is barely warm. How interesting is that? And that's definitely a Dash 25 part. All right, let's do cache check. Let's find out what we got going on with the cache. Yep, it's, oh. No, this appears to have 32K of cache. Now, what I don't quite know is maybe some of this cache memory is bad? I don't know. But you know what? Notice that the performance of this RAM is far faster than the other 386 board, which, if I recall, this memory up here, like when it was not being cached, was like 100 and something. So it was almost, I don't know, it was like 30% slower than this thing. All right, should be done soon. It takes longer because there's more RAM on this board, and with this cache check program, it needs to go up to 16 megabytes. Okay, wow, looks like megabyte 13 and 15 aren't cached. Yeah, because look how slow this is right here. Yeah, because the timing was really slow on those. That's weird. And yeah, 32K of cache memory. It's definitely got 8 64K chips here, which when we go back to this 486 here, it's also got the same 8 chips. In fact, it's the exact same chip, same part number and everything. And this had 64K, and that is only showing up 32. So it's got to have bad cache memory. There must be some issue there. And maybe that has something to do with why some of the memory is not being cached. Ugh, I keep knocking this little thing over with the jumpers. Maybe Intel's cache controller chip can't cache all that memory. I just don't really see why 14 is cached and everything above 13, like 0 to 12 is cached, but 13 and 15 aren't. Very unusual. Now, if this video weren't getting so long, I could test these cache memory chips. These are just normal SRAM chips, and the RetroChip Tester Pro has no problem testing these. So I will probably go ahead and test all of these in there and determine if any of these chips are bad. I'll just do that off camera. But before we do, I want to test this Cyrix chip here. So let's pop out the old DX25 overclocked, and let's pop in this 40 megahertz speed demon chip here. Okay, there it is. Popped out pretty easily. Alrighty, Cyrix. As I said, I recall this chip just results in absolutely nothing. And if that's the case, then I'm going to send it for recycling. Yes, you can't see the postcard, but it's just showing 2 dashes. And this is exactly what I remember this chip doing. And like I said, I was given a motherboard, this was a number of years ago, that had this chip in it. And I just was like, oh, I guess the motherboard's bad. But then I popped out the chip, because I don't know. I never really assume that a processor is going to fail. They're just, okay, that's really stuck. Okay, there we go. You know, I should just double check that all the pins are there. I think I would have done this before. Yeah. Yep, everything looks good. All the pins are accounted for. 1993 Cyrix, USA, made in Japan, for OEM use only. Like I said, this was in a motherboard. When I took it out, I just put in a regular 386DX. It might have been this one right here. And, you know, it just started working. So, don't know what else to say. Other than that chip is just bad. How sad. It's such a nice looking chip too, with this gold writing on there. Where's that Mathco processor? Let's pop this in. Let's just double check that works. And then I will go and I will test first Deoxit. Then I will go test the SRAM. Try to figure out what the heck is going on. Where's pin 1? Okay, there it is. Same story as last time. Chip is much smaller than the pins on the motherboard. Yep, it's posting now, so all is normal. All right, I'm gonna go test that memory now. All right, I'm back, and I tested all 8 of the chips. They all passed in the Retro Chip Tester Pro, which is right here. So those work. Put them all back on the board with a little Deoxit, and no change. It's still only 32K here. I know it's not finished. There are a bunch of jumpers right here. Could be that there's a jumper problem. So I guess I need to try to find the manual for this thing and see about a configuration. I wouldn't be surprised if this had 2 ways to configure this memory, either as 8K, because that's 32K at 32 bits wide, or as a full 64K. This type of cache memory, from my recollection, was very expensive back in the old days. I mean, we're talking like the main memory on this thing is probably running at 80, maybe 70 nanoseconds. And let's take a look. The cache memory is 25 nanoseconds. So that SRAM is fast, much faster than the main memory on here. And because of that, it was very costly. I will let this finish and see if it has that weird problem where the 2 megs of RAM aren't being cached. And while we wait, I'm gonna go look up this motherboard, see if I can find jumper settings for it. Nope, still doing it. There it is. It's not caching 13 and 15. Weird. All right, I'm on the retro web up here. I know you can't really see it so well. 100 or 14,000 motherboards is in this thing. That's amazing. So I'm gonna pick Micronics. There it is, Micronics. And there it is. This is the Micronics 8386 ASIC cache. And there's a photograph of it. Excellent, there it is. Looking good with all the little stickers on it and everything. That matches up. This one still has the battery on it. Is the battery leaking? Let's take a look closer here. Not a high-res picture. It doesn't appear to be leaking. Interesting. Anyhow, supported speeds, 20, 25, and 33. Well, we know this one's running at good old 33. It does say a maximum of 16 megabytes. Looks like there is a download for the jumpers. This website is incredible. It really is incredible. All right, there it is, max onboard, 64K of cache memory. Yeah, jumpers, jumpers, and jumpers. All right, so there's some jumpers for the Mathco processor that I didn't touch. And there is a cache disabled or enabled jumper, and that's it. There is nothing about 32K. Base memory 640 or 512. Video BIOS caching, enabled or disabled. Non-cacheable region select. Aha! Non-cacheable region select. I don't think this is the problem. This appears to be for the cards here and the BIOS and stuff like that. All right, so most of these things are configured using dip switches, which are over here. So it looks like the video caching is currently disabled, so I'll turn that on. factory configuration, do not alter. Okay, that is off. That matches. 6 is monitor type, color or monochrome. It's set for color. 7, cache enabled. That's on. And then 8 should be off. And then switch block 2, serial. This is us do the serial port, stuff like that. So that doesn't matter. We'll leave that alone. BIOS selection, and then this non-cacheable region is a jumper. And the only thing about the cache is the non-cacheable part of memory, and that jumper is currently removed, which means that only D1000 through DFFFF is not cached. Everything else should be cached. So unfortunately, there's nothing to explain why it's only seeing 32K, and that we're only getting that very strange behavior with these 2 megs of memory here that aren't being cached. So I guess I'm wondering if like this cache controller chip is bad. I think I actually have another one. I took off a dead motherboard that had been ravaged by battery damage. There's also, looks like a PAL chip right here that is next to the cache chip. So that might have something to do with that, and that's not working. Let's see if SpeedSys runs. That's gotta be a problem with my copy here. This does not make sense that it has not run on any of these machines. I'm gonna turn this machine off and I'm just gonna copy a fresh copy of it onto this card here. You know, copying these files over, I just download them again from Phil's computer lab. They have the same size, date, and everything. I just think I've realized what's happening. I think you need to have HiMemSys running to get that utility to work properly. And I keep exiting out of the startup sequence there by holding down Shift. That might be the problem right there. So let's give that a quick try. If this works, then I'm sure there were a whole lot of people screaming at their screens. No, look, this is complaining about EMM386. So, okay, I think you have to run HiMem, but not EMM. Right, there goes. Okay, so that was my problem the whole time. I really need to get Phil's computer lab boot menu onto this card so I can pick, you know, HiMem only or both or none or, you know, that stuff. Okay, yeah, it's going, it's testing. I'm just gonna remove EMM386 and I'm gonna remove Smart Drive because it was complaining about that as well. I think that's for like the disk speed test, which honestly does not matter because this is a, you know, it's a slow thing here. So I really don't care about that, but we'll just do that anyways. And we'll do a quick reboot, fix the camera. And now I know, I need to put like a note in that directory. You know, I have the math coprocessor installed in here and it's not even running. Why don't I just fix that really quick because I have the jumper configs right here. Number enable, MPU enabled is switch 1/2. There we go. Now it's on. I should put a README in the file with SpeedSys, in the folder that is, the directory. So it's late, everyone. It's almost 2 in the morning. I need to get to bed. This will be the very last test before I end this video. But I'm glad that I was able to test these motherboards. They've been sitting around in the basement here for a while, and I don't like having things that are untested because if it doesn't work and there's something fundamentally wrong, well, it could either be a repair video or I can just recycle it, you know, and take the parts off of it that are valuable and recycle the rest. So I like to test stuff, then I can put the tick marks on things. I mean, is this thing working or not working? Because we obviously have this pseudo malfunction of the cache. I'm just gonna put a tick mark down here. Oh, incidentally, I put Deoxit in those cache chip sockets. So, you know, they have a good contact, but I did not take out the cache controller chip. Maybe I really need to do that. It has this sticker on here, so obviously don't think anyone's ever touched that thing. Now, SpeedSys definitely gives us an indicator of like what kind of cache performance and if it's working. Memory bandwidth, 65 megs per second. Well, it's testing the processor benchmark, so we'll just let this run for a second and then we'll be back. There it is, 5.91. It's on the bottom of the scale. 36DX40 is at the bottom there. Yeah, and then here's the memory performance, and indeed 32K, and it drops right down. That yellow line should be going flat all the way to 64K, which is right there, and then drop down. So definitely something's wrong with the cache on this board. It is not fully functional like it was on the other 386 board, the one that was bent. So yeah, I guess at this point I'm asking, Has anyone ever experienced this kind of problem with this? Cache memory works, but we're only seeing half of the cache memory. So what's going on? Is it the cache controller chip? Is it one of these other chips here? I mean, I don't think these jumpers have anything to do with it because I looked through the list and none of them are related. So it's pretty confusing what's going on. But I guess I'm leaning towards this cache controller being the issue. I suppose actually because I happen to have one right here. This is, oh, it's a 25 megahertz one though, 82385. So it's the same part as that, but it's slower. I'm gonna swap it out. Let's see if that thing can overclock as well. And if it can, then we're golden. And if this fixes it, oh, this is hard. I can't even get my tool in there. See if I can get this out with the correct tool. I think this chip is very stuck in there though. I don't like using flat blade screwdrivers under a chip because it can crack the ceramic case. But this one is really, really stuck in there. It's pushed way down into the socket, which means, did that lift it at all? Yes, okay, I lifted it a little bit. So it's pushed way down to the socket, so I can't even get a thin screwdriver underneath it. All right, it's lifted up a little bit. So I use this metal here, so when I pry it against the motherboard, it didn't scratch it. So now I should be able to get the chip lifter in there. Yep, I can. Just, wow, this chip is stuck in there. Once it starts to move though, I can use this tool to try to get it out. Oh yeah, that's lifting it now. Cool. All righty, there we go. It's out. So as I said, same part number, but this is 33 megahertz. Let's pop in this 25 megahertz and overclock it. I mean, if this doesn't work at all, I can change the crystal on the board, which is not socketed, to underclock this thing. Okay, notch is in the corner. Oh, let's deoxit the socket first. Socket's really clean though. Okay, there it is. Cache controller chip in, notch is in the right spot. It's overclocked. What's gonna happen? It's posting. That's a good sign. Okay, cache check. Here we go. We'll know pretty quick if this thing is working at 64K cache or not. And it is not. Okay, so that's not that chip. I'll let it run through and just to see if it's going to have that problem with those 2 megabytes. But that implies that something else is wrong. And this PAL chip here, that's screaming that that might be the fault right there. I don't know. All right, it's almost to the megabyte that wasn't being cached. I think it was 13 and 15. Let's see what happens. You know, it's funny. And now that I think about it, that just could be the way that this cache controller works. It just may not cache those 2 megabytes, like on purpose, like Intel. Yeah, no, that didn't cache it. Okay, so Intel might have designed it where they didn't cache those 2 megs for whatever reason, like you needed to run some code that needed to not be cached. I don't know. But it is interesting that I am not only overclocking the processor from 25 to 33, but the cache controller, and that's working. I'm just gonna pop out this PAL chip here, and we'll see if this thing still works, like the computer still boots. And if the system still boots, then we can go check the cache memory if that's still available or not. So yeah, just a normal TI. It's a PAL 20L8. It's just a normal PAL chip. It's posting. So let's see if this disabled the cache entirely. Now the socket that was in is clean, no corrosion, nothing like that. Now there are a couple other 74LS logic chips around there. Maybe those are somehow related as well, if this does disable the cache. So I suppose I could check into those, but this is way more repairing than I normally want to do on these types of videos. Only because, yeah, the time is ticking by and I gotta get to bed. I'll do that shortly. I was watching a RetroBytes video here on the history of ARM. Yes, ARM as in Acorn Risk Machine. Okay, cache check, here we go, 33 megahertz, it is working. So it's funny, take those out, system's still working. It's still running with, what does this chip even do? It's still caching. Is this bad? And the fact that it's bad, actually, the reason why the caching is not working properly, because this is needed, this maybe is needed to actually run full 64K, And with it out of the board, the system just appears to be working just as well. So that's a bit funny. All right, well, anyways, I'm gonna put that back in. I think at this point, I'm gonna call it for this board. It mostly works. I'm just gonna show up close on this video. So anyone who wants to have a stab at thinking why this isn't working can let me know. Oh, get this video card out. There we go. So there it is. So basically, this is the cache controller. That was the PAL chip I just removed. It didn't seem to have any effect. This is the 64K of cache memory, which is absolutely definitely 64K. And I checked all of it in the RetroChip Tester Pro, hence the check marks. All of that is good. The motherboard appears to be working fine otherwise, but it's quite possible that some of this logic chips here might have something to do with the cache memory. I'm just gonna take a quick look at the bottom here. There is a bodge wire there, which is near the cache controller. Now looking at the traces, that's the PAL chip. I can see some traces going up, well, over to here, which is the math code processor. Maybe the math code processor wasn't working when I took it out, but I also see traces like to there, and they're actually, these are the cache chips right here, and there are traces right there that are going down to that PAL chip. So that PAL chip's definitely involved, but so are these other logic chips right here. Looks like we got 74 fast 573. That's this one right here. And then over here we have another 74 fast 573. And then we have also 74 F74. So maybe I need to do some scoping. Get the oscilloscope out. There's some scratches on the board right here. Must have been stacked on top of another board. In fact, it's probably not a bad idea for me just to look for any kind of broken traces under here or scratches that are, no, nothing in this whole area. The only scratch is up here, and I would say that that's unrelated. Anyhow, if you have any ideas what might be wrong, or if you've ever like done any fixes, let me know. But maybe that'll be a future repair to kind of try to dig into what's going on here. Because like I say, definitely something's wrong with this board where not all the cache memory is being recognized. Schematics would certainly help, but at least I know that these chips here are probably going to be related, and talking to the cache controller here. So it's got to be something in this area at least. What a cool motherboard though. Otherwise, very cool. See all this memory, all these onboard peripherals, overclocking a processor, and it's all working. Anyways, pretty neat. So that's going to be it. 4 motherboards. All seem to work perfectly, except for this one with a very slight problem. The rest are all good. Got to see a cool overdrive processor. Got to see a neat 286 motherboard that has a couple onboard peripherals. That's cool. And then that other 386 board, which is a DX board, and it just worked as well. And it's all pretty cool. So yeah, if you like this kind of video, thumbs up would be great. Let me know in the comments what you think about it. If you have any ideas about this stuff, definitely let me know in the comment section. And I really want to thank my patrons. Their names, they're scrolling up the side of the screen over here this time. They get early access videos, stuff like that. And you can become a patron by clicking the link in the description. And yeah, that's going to be that. So stay healthy, stay safe, and I will see you next time. Bye.